Hello there. I am making a quick video. I had to come to my house to do it because I forgot I didn't have my camera up at work. But anyway, I'm making the video I promised you that finishes out that review we were trying to do today because I don't know if something happened in the cosmic universe and stole 20 minutes of our class. I don't know what happened. But anyway, number 6, 7, 8, and 9 on the review is what I'm going to go through now. So let me go through and just go back to the document so we can kind of look at all this together. So we got through number 5, and this is number 6, where we're going to write a linear function. So it says, assume the growth of a membership of a country club was linear from 2006 to 2018. The starting membership in 2006, so they're naming that start year again. The starting membership in 2006 was 228 members, and it grew at an average rate of 15 members per year. So it says it was a linear behavior, so we should be able to write a linear function to describe the number of members. So that's what part A is asking about. Write a function, it means a linear function, m of x, for the membership as a function of the number of years after 2006. So the X and Y, we've got X is years after 2006, and Y is the number of members. Okay, because it says membership is the function. So that's the output. Okay, so if we want to do this, they don't really give us ordered pairs to work with. So if we think about in general what the linear function looks like, we can call it, what do we call it? M of X. We don't have to call it Y, but this is what we're looking for. If we know how it's changing and we know what the initial value is, then we can write the function. Okay, so if we look through here, since membership is what we're being asked to write a model for, we're looking to see if there's anything that tells us an initial membership, and there is, because it says we're looking at the time period when it was started at 2006, and it gives us the starting membership in 2006 was 228 members. So that means our B value is 228. That's our starting amount. So this is from section 2.3, where we talk about slope. And no, 2.4, we talk about both parts of a linear function. The constant is considered to be like the initial or starting value of whatever it is it's going to change. And then, of course, the slope number with the x is how it's changing. So the constant being B and the starting membership being 228 is how I get this. Now, there must be something that tells us how it's changing. And of course, that's what the last part of this says. The membership grew. So that's a code word like increasing, decreasing. Growing is like increasing at an average rate of 15 members per year. So there's all kinds of stuff around this 15 that tells you in words that 15 is the slope number, it's the change number. We see a word that refers to something increasing. It says it grew. We see that big major word that talks about rate. So rate or rate of change is the most common application of the idea about what slope is telling us. And then do you see these change units? You have Y units per X unit, members per year. So all this around this tells us that 15 is going to be the slope. If we look at the next year after the present year, we look 1 year in the future, we'll get 15 more members. Okay, so that means our slope is 15. And we just put this together, make sure that the 15 goes with the input variable. So the 15 is going to go with the X, and the 228 will be a constant term all by itself. And of course, you can write it kind of chronologically. We start at 228, and then we add the 15X for every year after that. Doesn't matter which way you write those terms. But there's our linear function that starts at 228 and grows by 15 members per year. Okay, so based on this, they're asking us just to use the function to estimate the membership in 2015. All right, so we have to decide if we're going to plug 2015 in for the X, or if it's one of those where we have a realignment. And it does say in part A, let X be the number of years after 2006. So we don't want to use the whole year of 2015. What we want to do is figure out what the difference is between those 2 years, and it's 9 years. So we're going to use X equals 9. So when we plug that back into the problem, I don't remember. So I don't have my key here, so let's work it out. 15 times 9 plus 228 gives us 363. So it would be 363. If it's a word problem, like when it's asking about the membership, then we need to actually put units on our answers. Okay. All right, so that's number 6. It's talking more about identifying slope and initial value to write a linear function. This would be like a model. And then we use the equation up here to plug in a specific number for a specific year to get a prediction. Okay, so that's number 6. Number 7. Okay, this is from 3.3 that's just talking about the slope concept. So it says when we're selling 10 units, a business generates a profit of $750. When selling 20 units, the profit is $1,000. So we've got two ideas. We have the units that are being produced and sold, and we have the profit dollars. Okay, so in terms of trying to figure out which one is which, input and output, what is the rate of change of the profit per unit sold? All right, so if we're talking about the profits or what are changing, that's our output, and see how profit per unit. So unit would be the X. So on all of this, we're going to have the unit, number of units is X, and the profit dollars is Y. And so we're going to form a couple of ordered pairs here. So we have 10 units generates a profit of $750. And then we have 20 units generates profits of $1,000. So there's our two ordered pairs. We're going to run this through our slope formula, which will be provided to you on the last page of the test. Subtract the Y values on top, subtract the X values on the bottom. So 1,000 minus 750 is 250. And then 20 minus 10 is 10. And then 250 divided by 10 is 25. So this is the rate of change of profit per unit sold. So if we sell one more unit, we make another $25. So that is the answer. And if you look at parts B and C, this is that idea of slope being expressed in different words. Rate of change, $25 per unit sold. What is the marginal profit? Marginal also means the slope. How much is it changing for an individual unit? $25. There's no extra work that we have to do on part B. How much will profits increase from the sale of one more item? Marginal rate of change. All of those just mean report the slope. So it's going to, if we sell one more, profits increase by $25. Okay, so if I'm doing rate of change, maybe I do $25 per year just to get the units right for change, but it's the number, $25 is going to be the same for all three because it's really just asking different interpretations on the slope. Okay, so number 7 was from 3.3, and that was just about slope. Okay. Then we're going to get into chapter 2 a little bit. So all the rest of this is from 2.1. So let's look at our first one, 8A. We have to solve a little bit here. Remember, there's also formulas in there. You might look at the online review for practice with solving formulas, but I just picked some random ones from the homework. So solving something like this for the X, that means we need to get something where we figure out what the value for X is that makes this whole statement true. Find where the equal sign is. Make sure we've simplified everything on both sides of the equal sign before we start moving stuff around. So in this case, there's parentheses that need to be expanded. So 3x plus 6, and then minus 6 equals 5x plus 4. Okay, so now that we've expanded the parentheses, this is what we have. We're trying to put together any like terms, which these constants, plus 6 and minus 6, cancel out. So that'll just give us 3x equals 5x plus 4. And now both sides are simplified, so now we just move the x's to one side and the numbers to the other. So if we move the 5x over to join the, I'm kind of losing space here. I'm going to do 3x minus 5x over here, and then I'll have the 5x plus 4 minus 5x. So this is what I'm doing to both sides. I'm subtracting that 5x to get rid of it from the right-hand side, and that'll give me a negative 2x on the left equals 4. And of course, when you divide that out, that tells us x equals negative 2. You can always check your answers on equations by plugging in negative 2 to the side on the left and see what it gets. Negative 2 plus 2 is 0. So all that's going to turn into 0. 0 minus 6 is negative 6. And then over here, if I plug in -2 for the x, I get 5 times -2 is -10. -10 plus 4 would equal -6. So -2 is the value that when you change x to that number, you get the same answer on both sides. I get -6 over here and I get -6 over here. So the number that I plugged in for x, that is the solution. Okay, now on the next one, we're doing the same thing. We've got t as our variable and it's on both sides of the equation. There really isn't any simplifying that we can do on either side here. What we're going to do though is just go to the step where we're collecting our like terms together. So since the t's are on both sides, I'm going to move my t term to the left by subtracting that 1.29. Don't know it in my head. So we've got 5.24 minus 1.29, 3.95. Okay, so that gives us 3.95 t equals -3.95. Well, it just so happens we get the same number on both sides except for the negative. So divide both sides by 3.95 and it would give us 1 or -1. Since the signs are different, it's going to give us -1. Okay. So those are just getting the x by itself or the t or whatever, t or whatever variable it is. Simplify each side separately, then collect your variables on one side, move your numbers to the other side. On part 8c, this is a little bit different. They give us the whole function, f of x equals just one expression, and they say, what is the zero of this function? So remember, to find a zero, you need to say what value for x would make this entire expression give an output of 0. So when you're given the expression like this, if you need to find a 0, you set it equal to 0. It's also the x-intercept. So if you're looking at a graph, just look at where it hits the x-axis. If you're given the expression and you're asked to find the x-intercept, you still set it equal to 0 because x-intercepts are where y equals 0. So there were different words for 0. There was zeros, there was x-intercepts, there was the solution when you set your function equal to 0 like I'm doing right here. Okay, so now to solve it for the x, I'm going to move that 84 to the other side. Divide both sides, and I believe that's 20, -20. So let me just check and make sure I've got my decimal in the right place. Divided by 4.2. Yeah, it's going to give us -20 for that one. So -20 is the 0. When you set up this equation, take the expression, make it equal 0, and then solve it. Okay, next. Now we're into a couple of word problems. You know, there's no formulas up here, but go check the online review if you want some different kinds of expressions to look at as well, different kinds of equations. Okay, now all of these are just the different kinds of word problems. We have 2% change problems here in the middle, and we have like an average thing on the top, and then there's a kind of a linear function on the bottom. All right, so on part A, I know everybody knows how to average tests. If I just wanted to find the average between 4 tests, I would add these things up and then divide it by 4, and that would give us the average for those 4 tests. But this is asking for 5 tests. What does she need to get on the 5th test in order to average a 91% across all 5 tests? Okay, so let's just set up, there's different ways you guys can do it. I've seen people just plug in numbers till they find the right answer, but I'm going to use some algebra, obviously. So I'm going to pretend like we're averaging 5 tests. So I'm going to add up the ones I can see here together. 88 plus 94 plus 92 plus 82. That's 4 of the tests. I'm being asked to figure out what would we need to get on the 5th test. So we're assuming that we're averaging 5 tests together, and I don't know what it is, so I'm just going to call X is the 5th test. Okay, so there's 5 tests, 4 that we know and the one we don't know. So we have to divide that by 5, and we want that to work out to be whatever the overall average is that we're looking at, which is 91%. Okay, so that's how we do this problem. And in order to solve it, I would probably add all those 4 numbers together first, kind of simplify that numerator. Let me see, so 88 plus 94 plus 92 plus 82 is 356. So I'm going to kind of continue this over here on this paper next to it. Okay. So that would give me 356 plus x over 5 equals 91. Okay, so now that we've got this equation, kind of simplified my numerator altogether, make sure 94, 92, 82, yeah. Okay, so now I would do the thing I was doing before. I would clear fractions, just times both sides by 5. It would give me 356 plus x equals, what would it be, 455, I think, times 5. Yeah, it's 455. And then basically you just take and subtract the points you've got from how many points you need. So 455 minus 356, that'll tell you how many points you need on the fifth test. So it's barely possible, but it is possible. 455 minus 356 is 99. So this person technically could get the 91, but they'd have to score 99%. I don't know why they're not going for just 90%, but that's not the question that was asked. So there we go. So that's just one of the ways that you can work out what's the last test need to be for the whole average to be a certain amount. Just set it up like you would do an average with all the numbers you know. Throw an X in there to represent the one you don't know. Make sure you divide by all of the tests, including your unknown, and make it equal the thing that you're shooting for. Okay, then you're going to times this on both sides, and then add all those points together and subtract it from whatever's over there. Okay, that's our first word problem. Now B and C, I want to remind you about our percent of increase and our percent of decrease. This is kind of how I had you set it up. I know there's other ways to do it, but if you take the original amount, if you want to increase something by a certain percentage, if you change that percentage to a decimal, add it to 1, that's what you multiply to get the new amount. Okay, so that's a percent increase right there. 1 plus R times the old amount equals the final or the new amount. If you're doing a percent decrease down here, you start with the bigger number, old amount, you're reducing it by that rate, so it's 1 minus R, and that's how you get your new amount, which will be smaller in that case. So that's a percent decrease, and this is a percent increase. Basically, the R is positive if you're increasing, the R is negative if you're decreasing, you're subtracting. All right, so let's look at what we have in this problem. So if it says the receipt total was 5160, I believe that means including tax, and the tax rate was 7.5%. So what was the subtotal not including the tax? So we're trying to work our way backwards. After we did a 7.5% increase with taxes, the final amount was 5160. So the 5160 is our new or final amount. The rate, if it says 7.5%, that means what we're going to use for R is take 7.5, divide it by 100, or take wherever the decimal is and back it up 2 times. We're going to need to put a 0 in front of that 7. Okay, so that is what we add to the 1 to multiply against our mystery amount. So what was the subtotal not including tax? Don't know what that is, so I'm going to call that X. I'm going to multiply X by 1.075 because I'm taking 1 and adding it to a decimal. You just put 1 in front of the decimal, and that gives us our final amount. So when we're going to divide both sides to get our original amount, I believe when you divide those together, you get $48. But it's just, especially for the percent increase problem, it's really easy to set up. If you're given the final amount and you want to get back to the original amount, you take your final amount and divide by 1 point, whatever the percent is as a decimal. Of course, if you know the old amount, you're trying to get to the higher amount, you just multiply times 1 point, whatever it is. But typically on these, the one that takes a little bit more thought is how to get back to the original amount once you have the final amount. Okay. Part C. Same kind of deal, except it's being discounted. So we have a percent change, but it's going downward. So if a smart TV is on sale at 25% discount, so something has been marked down, has it had a percent decrease of 25%. And the result of this new lower price is $450. So we're wanting to figure out, well, what was the full price? What was the price before the discount? So in this case, the new sale price is going to be over here. We don't know the old original full price, so that's where our X is going to be. And since it says 25%, that means our rate is going to be 0.25. Okay. Now, so we're going to take the old amount, old previous price before the discount is X. So we took our original amount. This time we reduced it by 25%, like that. And that gave us this new sale price of $450. So that's our setup. Well, this you have to maybe, if you can't do this in your head, you might have to do it with a calculator, but you're going to take 1 minus that decimal. I believe we said this in class last week. If you remove 25%, what you have left is 75%. So this 450 represents 75% of whatever that starting price was. So now we're going to divide both sides by the 0.75 and get 600. So the full price TV, that's a expensive TV, but the full price TV is $600. If you mark $600 down by 25%, you get a sale price of $450. Okay. If they ever ask you, or if I ever ask you instead, what was the amount that it was discounted by, you just subtract the $2 amounts. Okay, we're almost done. Last question is just about, you can set this up in so many different ways. I'm going to obviously kind of set up a function and use some algebra, but a car rental company charges a rental fee of $50 plus $5 per day. All right, this means flat fee of $50, even if you just go get the keys and you never leave the parking lot with it. When you return those keys, they want $50 because nobody else could drive that car as long as you had the keys. So $50 is sort of like the starting amount you're going to pay. That's the lowest amount you're going to pay. And then for every day you have it out, another $5 gets added in. So this is the part that changes. See dollars per day. So that's like a slope number. If I let X be the days, and it's asking for X, for how many days could a car be rented for $135? Okay. Now, some of you may not even think of it like this. You get what's going on here. You go, okay, well, it's like if I had $135 in my hand, how long could I take that car for? Well, I had to pay the $50 off the top. So 135 minus 50 would leave $85. And then how many days could I get with $85? I could divide that by the $5 per day. So you can kind of just reason it out like that. You can also just do this calculation for a bunch of different days until you just guess right on the one day and you get the 135 for the answer. But I'm going to go with like a direct way here, with uses a variable. So how many days, and let that be X. So we have $50 to start, plus 5 times I don't know how many days. That's what I'm trying to figure out. Like for what value of X, so for how many days will this thing work out to be the 135 that we're looking at? Okay, so this is solving this is exactly the same steps as me just talking through it, like I said before. So to get the X by itself, I subtract 50 from both sides. That'll give me 85. And then divide that by 5, and I believe it's 17. So it'll be 17 days. That'd be quite a road trip. But 17 days is how long you could keep a car like that out if you have $135 under these conditions. $50 flat rate plus $5 a day. I believe it's actually way more expensive than that to rent a car. So I may need to update my numbers here. Okay, so that was the rest of the review that I didn't get a chance to do together in class. Starting with number 6, we did this Desmos kind of problem here together where we wrapped this function in Desmos and then we used a graph to answer these questions down here. So C of 5, we would just type that into the Desmos and it would give the answer. When it's talking about a minimum, remember when you're graphing a function, if you go and put your cursor anywhere on the graph and click on it, then it will highlight these turning points. If there's any intercepts, it'll highlight those too. Once those little gray points have popped out, you just roll your cursor across it and the coordinates pop right up. Okay, so remember the coordinates, the X value is the input that produces the minimum, and the output is actually the minimum function value. Okay, so that's it. Let me get this thing saved so I can get it sent to you guys, and I'll see you on Thursday.